The square root property states that the solutions to an equation of the form x squared equals p are x equals the square root of p and x equals minus the square root of p. What this means is that we can solve this by just taking a positive and negative square root of the side of the equation that does not contain the x squared. If we want to use the square root property on an equation like this, the first thing we want to do is isolate the variable, and we isolate this in the simplest way possible. We want to get this squared expression alone on one side of the equation and have our numeric expression on the other side. So in order to do this on this particular equation, we can just divide both sides by 3, which would turn this into the equation x squared equals 25. Now applying the square root property, we get that x is equal to the square root of 25, or x is equal to minus the square root of 25. And since 25 is a perfect square, this gives us two very simple rational solutions, x equals 5 and x equals negative 5. We can also adapt this property to somewhat more sophisticated equations. As long as it's in the form of a squared expression equal to a number, it can be something other than simply x. If we take, for example, the equation that we would get by solving this function problem here. In this example, the function f of x is defined by the formula x plus 4 squared, so we can substitute that expression into our equation to turn it into an algebraic equation which we can actually solve. In place of f of x, I will write x plus 4 quantity squared. The equals and the 16 will stay where they are. And now I have an equation that is in the form of a squared expression equal to a number. Applying the square root property, I can write this as x plus 4 equals the square root of 16, or x plus 4 equals minus the square root of 16. Again, 16 is a perfect square, so we can evaluate it and get two rational solutions. The square root of 16 is 4. Subtracting 4 from both sides, on this first equation I end up with x equals 0. Subtracting 4 from both sides on this second equation, I end up with x equals negative 8. What both of these equations have in common is that their solutions were rational numbers, so the process of finishing up and simplifying our answers was just a matter of evaluating the square root and then combining terms. This is not the case if we have another kind of number in our solution set, such as an irrational number or even an imaginary number. In this next example, we have again an equation in the form of a squared expression equal to a number. So when we apply the square root property, this becomes x minus 1 equals the square root of 15, or x minus 1 equals minus the square root of 15. This time, because 15 is not a perfect square, we are going to have irrational solutions, and we cannot completely get that square root out of our answer. We can't simplify the square root of 15, so what I'm going to do is finish solving for x by adding 1 to both sides of each of these equations, so that I get x equals, keep in mind now that these are not like terms. I can't add the 15 to the 1, but I can write this as a sum of two not like terms. Because they're not like terms, I can't combine them, and I'm going to have two terms in my solution. Same thing over here on the right hand side. I'm going to end up with x equals 1 minus the square root of 15. It's okay to put the terms in either order, but it is a little bit more common to put the irrational term second. So my exact solutions are these ones that I get just by simplifying as much as possible. 1 plus the square root of 15, comma, 1 minus the square root of 15. And it would also be fairly common in some cases to just write this as 1 plus or minus the square root of 15 in order to use a shorthand form to summarize the two solutions. If we want a decimal approximation, we're going to have to get a calculator and approximate the square root of 15. It's usually a good idea to try to enter the whole expression at once rather than to try to just get the square root of 15, write that down, and then plug it in again. So let's bring out our calculator. Now all calculators are different. This is a fairly simple calculator that will just take the square root of whatever is on the screen when I'm at that step. So what I need to do here is write 1 plus and then do an open parenthesis, 15 square root, then a closed parenthesis to get my decimal value, 4.8729. If this is to 3 places, I'll write that as 4.873. And then the second expression, 1 minus 15 square root, it's taking the square root of 15, equals, and I get negative 2.873 if I round that again to 3 decimal places. So negative 2.873 as my second solution. If we have two different solutions, we definitely need two different decimal approximations. Going on to this next example, this equation is of the form x squared equals a number. I'm ready to go ahead and apply the square root property right away to get x equals the square root of negative 4, or x equals minus the square root of negative 4. Be careful about exactly where you're putting your signs. Remember that with the square root property, we really take the whole number here as our radicand, that is, as our expression that we put inside the square root. So it's very important that this minus sign be inside the square root. This makes a really big difference in our final answer if we don't get the sign placement exactly right. We know from simplifying radicals with negative numbers, and when we studied complex numbers and imaginary numbers, that this can be treated as the square root of 4 times the square root of negative 1, which becomes 2 times I. So my first solution is x equals 2i, and my second solution is going to be x equals negative 2i. For this final equation, it's recommended that you pause the recording and try working it out yourself to see what answer you get, then see what answer we get in this recording. In the first step, I would apply the square root property to get x minus 6 equals the square root of negative 25, and x minus 6 equals minus the square root of negative 25. Of course, we can simplify the square root of negative 25 by thinking of that as the square root of 25 times the square root of negative 1, and writing it then as 5i. So this first equation becomes x minus 6 equals 5i, and the second equation becomes x minus 6 equals negative 5i. Now adding 6 to both sides. These are again not like terms. We can't combine them. but we can write them as complex numbers. So this first one becomes x equals positive 6 plus 5i. And remember that in a complex number, you would always write the real part first and the imaginary part second. X equals 6 minus 5i. That's why I'm writing the 6 first and the 5i as my second term. One thing that makes this process for solving equations a little bit tricky, even though it is a lot easier than some of the other methods for solving quadratic equations, one thing that makes it tricky is that the kind of solution you have in the end determines what the process is going to be like along the way. When we had two rational solutions in our first two examples, we saw that at this stage here, where we were adding, we were able to combine those terms into a single number. In the irrational and imaginary examples, if there's a number to add to both sides, you most likely will not be able to combine those terms and you'll get a two-term solution. So it's important to be very careful at each step and not assume that it's going to work out exactly like the last problem that you may have worked on.